In this video, we will show how to draw the ray diagram using lenses, that is the convex and concave lens. The first one, we will show the image formation by a convex lens for the object beyond 2f1. To draw this, we have to draw a line and divide it into 4 equal parts. So first of all, we will draw the line. So now we will, this is 2f1, this is 2f1. Now equal parts, 3, 6, 9 and 12. Okay, this is 2f2, this is 2f2. Now we'll place the compass in 2f1 and 2f2 as the center of curvature, as the center of curvature. To draw the lens, we are taking an arc same way from 2f1 with the same arc. This is the lens. You can rub this one to make it more clear. This is the optical center. We'll draw a line through the optical center. Now, image formation by a convex lens for an object beyond 2f1. This is the object beyond 2f1. I am drawing an object beyond 2f1. Okay, so this is the object. Now, I will pass one incident ray parallel to the principal axis. The first incident ray will pass parallel to the principal axis. So this is the first incident ray, and the second incident ray will pass through the optical center. The first incident ray is drawn parallel to the principal axis, and the refracted ray will pass through the focus according to the rule for the drawing the ray diagram. The second incident ray will pass through the optical center, and it will pass undeviatedly, that is in this direction. In this direction, an arrow is must. Okay, so the image is formed between f2 and 2f2. The image is formed between f2 and 2f2. Now, the characteristics of image formed by the convex lens when the object is placed between beyond 2f1. Now, it is inverted image. Inverted. See the arrowhead. The arrowhead of the object is upright, whereas the arrowhead of the image is formed inverted. That is, the image is inverted. It is real image. Why real image? If the object and image are on the opposite side of the lens, it is considered to be a real image, and it is diminished. So the characteristics of image, number 1, characteristics real image, number 2, diminished, number 3, inverted. So these are the characteristics of image formed by the convex lens when the object is beyond 2f1. First, if the object and the image are on the opposite side of the lens, the image will be real. Next, if the size of the image is smaller than the size of the object, the image is said to be diminished. And we'll have to notice the arrowhead. The arrowhead of the object is upright, whereas the arrowhead of the image is inverted. That's why it is inverted image. So these are the characteristics of image. Now we will shift to the next diagram. Now the second one, image formation of a convex lens for the object at 2f1. Again we have to draw a line. We have to draw a line like the previous one. Again 4 equal parts. I am starting from this point. 4, 8, 12. Seven, 10, 13. Okay. 4, 7, 4, 7. I'm rubbing this point. 10 and 13. Okay, so these are the 4 points. Now 2f1, f1, f2, 2f2. We will place the compass, that is in 2f1 and 2f2, as the center of curvature to draw the lens. We are taking any arc. So this is the optical center O. Now the object is placed at 2f1. I am drawing the object at 2f1. This is the object at 2f1. The first incident ray, I will draw it parallel to the principal axis. Okay. If the incident ray passes parallel to the principal axis, then the refracted ray will pass through the f2. Arrow is must. The second incident ray will pass through the optical center. That is okay. So the arrow is must. Until and unless you will draw the arrow, you will not get any marks. Now the image will form at 2f2. This is the image. So first, the object is at 2f1, the image formed at 2f2. Now the characteristics of image. That is, the image is real image. Why real? Because the object and the image are on the opposite sides of the lens, so it is real. Next one, the arrowhead of the object is upright, whereas the arrowhead of the image is inverted. The third one, that is it diminished or magnified? You just see that the size of the object and the size of the image are same, that is, they are equal. Therefore, characteristics number 1, real, number 2, inverted, and number 3, it is same size. So these are the 3 characteristics. Again, since the object and the image are on the opposite sides, therefore they are real. The arrowhead of the object is upright and the arrowhead of the image is inverted, therefore it is inverted image. And the size of the object and the size of the image are equal, therefore they are of the same size. So these are the 3 characteristics of image formed by a convex lens for the object at 2f1. The third one, when the object is in between f1 and when the object is placed between f1 and 2f1. Now again, we have to draw a line. Okay, the second step, we have to equally divide into 4 parts. Okay, 3, 6, 9 and 12. Now it is placed between, so first I have to write 2f1, this is 2f1, this is f1, f2 and 2f2. Okay, now the center of curvatures f1 and 2f1, we have to draw an arc to draw the lens. So this is the lens. We are rubbing this. We have to give a neat diagram. Okay. The optical center. This is the optical center. This is the optical center. Now the object is between f1 and 2f1, so we are placing the object between f1 and 2f1. Now the arrowhead, firstly we are taking the incident ray parallel to the principal axis as before. The refracted ray will pass through the focus, that is basically f2. Arrow is must. Okay, now the second incident ray will pass through the optical center, that is the optical center. Arrow diagram. Arrow. The object is formed at a point Now, the characteristics of image. Number 1, the object and the image are on the opposite side, therefore it is real. Number 2, the object, the arrowhead of the object is upright, whereas the arrowhead of the image is inverted. So the image is inverted image. Number 3, just look at the size of the object and the image. The size of the image is much larger than the size of the object, therefore the image is magnified. So the characteristics of image formed when the object is placed between f1 and 2f1 is the object is real, it is inverted, and number 3, it's magnified. So we will shift towards the fourth one. Now, when the object is at f1, I have drawn the lens as earlier. Now the object is placed at f1, I am drawing the object at f1. So this is the object. The first incident ray will be parallel to the first incident ray will be parallel to the principal axis, so I am drawing the first incident ray that is parallel to the principal axis. As we know, if the incident ray is parallel to the principal axis, the refracted ray will pass through the focus, that is the f2. Okay. Now the second incident ray will pass through the optical center. So, and this is the arrow diagram. So we are seeing that the image will be formed at infinity. The position of image is at infinity. Now the characteristics of image. Number 1, since the object and image are on the opposite side, number 1, real. Number 2, it is inverted. And number 3, it is highly magnified as it is formed at infinity. Okay, the image formed at infinity. As it is formed at infinity, the image is magnified. Okay, so these are the 3 characteristics of image formed when the object is placed at f1. When the object is placed between lens and f1, that is anywhere between O and f1, so I am drawing an object between O and f1. Okay, now the first one will pass, the first incident ray rather will pass parallel to the principal axis. Okay, the refracted ray will pass through the focus. The arrow is must. Okay, the second one will pass through the optical center. So we can see that there is no chance of meeting these 2 light rays, so we can draw the dotted line from here. This also, the dotted line. Just see, this is the diagram. So the characteristics. Number 1, the object and image are on the same side of the lens, that is virtual. Number 1, virtual. Number 2, both the arrowhead of the object and image are upright, therefore it is erect. And number 3, the size of the image is larger or greater than the size of the object, therefore it is magnified, and the image is formed between f1 and 2.1. Okay, so this is the only virtual image formed by a convex lens when the object is placed between the lens and the f1 or the first focus. Now is the turn for the concave lens. Formation of image by a concave lens when the object is at infinity. When the object is placed at infinity, so again I am drawing a line and dividing it equally into 4 parts. Now to f1, f1, f2 to f2. Again, taking this as center of curvature, you are drawing the concave lens. The concave lens we will draw like this. Okay, again from to f1 the same thing happens. So this is our concave lens. This is the concave lens. What is given? The image, the object is placed at infinity. So this is the optical center O. The object is from infinity. I am taking 2 lines. One, both are parallel to the principal axis, but one above the principal axis, the other is below the principal axis. The arrow diagram is must, so we are giving the arrow. We know that if the incident ray is parallel to the principal axis, the refracted ray will pass through the focus. And in this case, since a concave lens is a diverging lens, the light rays will pass in this direction and this direction. This is the refracted ray, and the extension we will find in the focus. Same way. This is the refracted ray, and we will draw the extension that will meet at the f1. So arrow diagram is must. So the characteristic of the image, since the object and the image are on the same side, it is virtual and upright. And the image is diminished to a point. Number 1, since the object and the image are on the same side, therefore it is virtual, upright. Number 2, it will be upright or erect, whatever, and the image is diminished to a point. The image is diminished to a point. Next. Now, when the object is placed anywhere between the infinity and optical center and anywhere between the lens. Okay, so I am taking the object beyond 2f2. Anywhere between infinity and lens, that is, we can take the object beyond 2f2. Now, the first incident ray, that will be parallel to the principal axis. Okay, arrow diagram is must. The second one will pass through the optical center. Arrow. Since it is a diverging lens, the refracted ray will pass in this direction, and the extended of the refracted ray will meet at focus. Now the image will be formed here, that is between the intersecting lines of the two refracted ray. So this is the image. Now the characteristics: number 1, since the object and the image are on the same side, we will say that it is virtual. This is virtual. Number 2, both are upright. Image and object both are upright, that is the image is erect. And number 3, see, the size of the image is much smaller than that of the object, therefore it is diminished, and the image is formed between the optical center and F2. So these are the characteristics of the image formed anywhere between infinity and optical center of a concave lens.